So in part C, we have this new tank Z, which has a top open and it has this shape. We're told the bottom of tank Z is connected to a short horizontal pipe with a closed valve, and it is again filled with water to a height of H0 above the horizontal pipe. And we are told at the start we open this pipe, and the question states that we need to see whether the speed Vs at which the surface of the water moves downwards increases, decreases, or remains the same over time as water exits the other end of the pipe. We need to justify using our answers from B1 and B2. So what we know is that the equation we have is Vp is equal to the square root of Vs squared plus 2gh. So what we can see is that as h decreases, Vp also decreases. And what we know is that the other equation we solved is that Vs is equal to r squared over big R squared times Vp. So just rearranging it. So what we see is that if r is increasing, so if r gets larger, then Vs becomes smaller as it's in the denominator. And so what we can say is that since Vp is decreasing with a decreasing h, we can see that Vp decreases and R increases, and therefore the speed of the water surface decreases. So Vs overall decreases. So we could also, well, this is technically a simultaneous equation. We could simply rearrange this for Vp and plug this in. So we could simply plug this into here so that we have an equation only in terms of Vs, and then we can rearrange for Vs. And if we do that, we get an expression in which we can see if h is decreasing and r is increasing, then Vs decreases. So again, we can see that the surface water speed is going to decrease.